Good morning or good afternoon, depending on where you are. Welcome to the fourth and final day of the 2021 AMS Washington Forum meeting presented by the AMS Board on Enterprise Economic Development. We have an exciting lineup today, and those highlights include I'm really looking forward to this, a keynote on AI policy and ethics, an area that I believe all of us are very interested in of late. An exciting keynote speaker, Ocean Enterprise keynote on the new blue economy with Dr. Rick Spinrad. A session 7 entitled The New Blue Economy, Provision of the Ocean Observation Products and Services Needed to Support a Growing Blue Economy. And then the final session of the day and of the AAWF for 2021 is Truth in Science, Scientific Integrity in the Public Sphere, Mistrust, Rumors, and Risk. A couple of reminders. Continue to enter sessions as you did for this session through the Join Now link. If you're a panelist or moderator, please remember to enter your session through the customized link that we've provided you. Given the virtual nature of this meeting, we must all re-enter each session through the Join Now each time or through the customized link. The Join Now links will be active 20 minutes before each scheduled session. If you have trouble accessing the sessions or have questions throughout the forum, please email meetings@ametsoc.org. For Q&A, please put your questions in the chat panel and notate panelists and attendees so that all can see your question. Our moderators will do the best they can with time permitting to address your questions to panelists. Please don't be shy. Recordings will be posted in the online program 72 hours after applicable sessions, so even late registrants will be able to log in and catch up very quickly, or in my case, re-listen to a number of them because they've been so fantastic over the past couple days. Feel free to tweet throughout the event, hashtag AWF 2021. Reminder about conduct, not contact. We want to remind everyone about our policy on professional and respectful conduct at AMS meetings, and that applies to all AMS-related events, including virtual meetings. I'd like to again thank our generous sponsors that have made this incredibly important AWF possible. Lockheed Martin, the Aerospace Corporation, AccuWeather, QBR, General Dynamics Information Technology, Ball Aerospace, Millersville University, Earth Networks, Commodity Weather Group, Vaisala, IBSS Corporation, and IMS Systems Group, and of course, a special thank you to our AMS premier sponsor, Maximus. Now, it's my pleasure to introduce Amanda Mitchell, who will kick off our AI policy and ethics keynote panel. Amanda, the floor and mic is yours.
Well, thank you, Jen. I really appreciate that. Welcome, everybody, to our first session of the day, and my first time moderating a session, so I'm really excited. The way this session came about is just having a discussion of how AI is being ever more popular as far as trying to implement across solutions of everyday life. And the things that we wanted to talk about, especially with AWF being more of a policy-centric type of conference, is that we want to know what are the different sectors seeing in terms of creating trustworthy AI, and how is it being monitored, how is it being gauged, what are they experiencing as far as policies and guidelines and standards. And we will hear that from a lot of our speakers from today. And we wanted to get a broad breadth of who can represent each of those sectors. So we have some private industry, and then we also have our representative, Jamie Sims from NOAA. So our first speaker for today is Kirk Bresniker. He is the Chief Architect of Hewlett-Packard Labs, as well as an HPE Fellow and Vice President. Without further ado, Kirk, please take it.
Thank you, Amanda. And oh, great, I can see my slides. So thank you, everyone, for inviting me to talk about this. It's very opportune as we at Hewlett-Packard Enterprise released 2 days ago. We released our global AI ethics principles. And I led one of the working groups across the breadth of our company over about 15 months to come to this point. So I think it's very timely for us to share, and what I wanted to do today was share my experience of being part of one of those working groups. So we'll talk about that, how we formed our policy, how we're reducing that now to practice. And it's one thing to have principles, it is another thing entirely to live them out and to drive that through a broad organization. And finally, I'll talk a little bit about labs and how our understanding, crafting our AI policy and driven from our AI principles is now forming some of our research agenda at labs. So if I could get the next slide. In terms of the governance structure, we have actually broken our governance structure into two pieces. We have an AI ethics advisory board. And in our enterprise parlance, this is L1s. These are individuals reporting directly to our CEO, Antonio Neri, and really representing the breadth of the company, every function. So it's not just the lines of business, it is also all the support functions, HR and finance, IT, all of those in addition to our lines of business. And they form that advisory board. We also strove to make sure that that was both people who were inside of the business and also all of our field-facing and partnership-led organizations. Then we have our AI ethics working groups, the teams that are down there constructing the policies, gathering now, having written our principles, gathering those use cases and educating and then engaging. And I think it's been a very interesting process for us. When we started out, we thought that perhaps the AI Ethics Advisory Board, it would be quarterly meetings like some of our other compliance functions where you have people fill out the forms and they get a yes or no, they get a simple answer. What we've realized, having worked so hard to achieve our principles that we'll show on the next slide, we really needed those to be driven into practice. And so that is going to be a continuous and ongoing process of education and engagement. So our AI ethics principles, again, this is what went out 2 days ago. Notice at the top is our purpose. You know, Dave Packard's 1960s says we come together as Hewlett-Packard Company to do what we couldn't do individually. We come to make a contribution to society. I think if you were to meet our CEO today, Antonio Neri, and it wouldn't matter if you were in the halls at labs out here in California or it was in the World Economic Forum, he would remind you within the first probably 90 seconds, the purpose of Hewlett-Packard Enterprise is to advance the way that people live and work. So our principles start from our company's purpose. Our purpose is to advance the way we live and work, to seek out and use and develop responsible AI with beneficial outcomes for people and businesses and public services guided by these AI ethics principles. You should read all these as AI should. AI should be privacy enabled and secure. AI should be human focused. AI should be inclusive. AI should be used responsibly. AI systems should be robust. And if we click down into each one of these, I think you should see the reflection of our engineering heritage in how we have crafted each one of these, especially in things like robustness. That's where hazards-based safety engineering principles incorporated here. But throughout all of these principles, we strove to reflect what we thought was unique. And what is not unique is the demand for people espousing and then demonstrating that they are living up to AI ethics principles. I'm sure that everyone saw the release last week of some new potential legislation out of the European Union, but we're seeing this globally. And what was important for us, and especially as we think of our field-facing customer and partnership engaging members of our team, they often will need to understand what is the relationship of our unique AI ethics principles that we have crafted over 15 months to reflect our particular contribution, and how do those compare to regional sets of AI principles. And this is because we are seeing increasingly that this is now expected. Request for information, request for proposal, request for quotes, all around the world, we're seeing that these are now included. What are your AI ethics principles? How will you demonstrate that this engagement will be one that meets and we can demonstrate that you are meeting your expectations and living up to these principles. And so we started our map, and whether it is Europe, whether it is China, India, Singapore, regional entities, whether the U.S., the White House has theirs, the U.S. intelligence community, the U.S. Department of Defense, all of them have, and you see they're somewhat aligned in that, and I think that shows that there is some commonality. Now, one thing we're expecting we're a global company. We either have direct business or significant partnerships, long-term partnerships in over 140 countries around the world. AI ethics will need to be understood in light of those regional requirements. Now, that doesn't mean that we will change our ethical behavior, but it does mean that we have to consider the local strictures, local regulations, if we decide to do business. And I think that is certainly a piece of this is all about providing people principles that then they can interpret, share their interpretation internally with us as the working group and the advisory board, and then proceed with their jobs, understand which things we will do, understand which things we will not. And when we come to one of those understandings, we're now really focusing on capturing that behavior and then driving it out and educating it, using it as the further education of everyone within the company on how we are living out our principles. So I get one more slide, please. So this is now what we are using as our AI ethical risk management framework. And you'll notice at the top, we talked about 3 categories. And this really is the fact that we are not just an IT company. We are a global Fortune 50-ish company. And so we have all the demands and needs. We have policy, we have process. And so one of the elements where we see this, and as a matter of fact, some of the most voracious users of AI within Hewlett Packard Enterprise are our marketing teams and our HR teams. And for them, it's more about understanding a procurement process. How do they go out and search for the best possible tools to use globally, because we are a global company having employees all over the world as well as partnership all over the world. How do they then understand how our AI ethics principles should inform their procurement operations? Then there is the partnership. There are the partners, the people that want to build on top of our infrastructure or our services to construct AI systems. What should we be doing in terms of searching out and understanding if a partner behaves according to our AI, in compliance with our AI ethics principles, and if we should, we are in fact using this now to help us select those partnerships. Sometimes it is a matter that they may, some of them may not have considered it or considered it with all the aspects that we have, and so it's an education and another education and engagement process for us to figure out which partnerships we think are compliant, which are affording us risk. And one thing that has come out of this discussion is that it doesn't matter that in some cases our infrastructure is substitutional with another provider. So just because you can get a server from Hewlett Packard Enterprise or one of our competitors doesn't give us a pass. So being substitutional is not an excuse for not requiring to consider our AI ethics risk framework. And the final thing is the products. When we are incorporating AI into our products to make the products better, sometimes it's not even visible to the end customer. All they know is that these products just getting increasingly better adapted, more robust, more agile, more resilient, and if they don't necessarily understand how it happened. We can tell them it's AI, and sometimes we do, but it's also it's forming and being pervasively applied in engineering itself. One thing I think, as Amanda said, this is a pervasive technology. We don't imagine that there is an aspect of Hewlett Packard Enterprise operations, again, whether it's process, partnership, or products, that isn't going to be affected by AI, that should not have everyone thinking about the AI ethical risk management framework. So for us, then, the AI ethics principles, you can see at the middle of the slide, that is our core. And then as it's whether development or acquisition, we go through, educate, engage, have a risk assessment. We understand if there is a mitigation that can be applied. And then finally, if there is, how do we assure that it's happened? And so this is now the process that we are beginning to go through. And one thing we realize, it can't just be a simple one-size-fits-all, even amongst these three categories. It is a process of engagement and education. And I frankly may expect to see us having to come back to our principles, extend them as we learn more, as well as develop all these use cases. Next slide, please. So that was about the principles, about the policy, about what we're doing now. One of the things we realized in going through and forming these principles, starting to understand and living them out, there are areas where we cannot apply AI yet and meet our ethical obligations. And there are a variety of the reasons for this. Again, we want to make sure it's privacy enabled, secure, human focused, inclusive, responsible, robust. Those are our principles. And for us, having things that is compliant, explainable, fair is not necessarily where the technology is today. And so what this is now forming for us is our lab's AI research agenda. How can we advance these technologies so that they actually can be admitted into a broader set of our most challenging problems globally, especially into those problems where we see heavily regulated industries, where that inexplicability of today's AI systems causes us to say, you know what, maybe this isn't the right tool yet, but how can we do it? Next slide, please. And this is my last slide, I believe. And so this is a busy slide, but there are just lots and lots of projects for us, but they sort of fall into three sectors. And then this is our research agenda at Labs: understanding and assessing trust, designing and synthesizing AI for that trust, and finally, that data foundation to capture trust metrics. So it's not just enough to say, I have made strides to ensure the quality of my data. It is understanding that now data forms an integral pipeline, a part of this process in a way it has not always been before. So the ability we've had in the past to audit code, to look at commit logs, now we have to understand all the way from the sensor to the training, to the inference, to the actuator. Again, that entire pipeline, that is where we talk about this data foundation that ensures we have confidence in applying these in those most sensitive, challenging problems that we have. So I think that's it. One last slide. I think it's just me saying thank you for the opportunity to talk to you today. And you can see my email there at Labs. And again, it's a fantastic discussion, one that has been very interesting for us to go through the process of generating our principles, and now that even more challenging process of living those principles out.
Kirk, that was amazing. Thank you so much. I loved all the slides. I can't wait to look back on them. I'm really glad these sessions are being recorded. So next up, we have Dr. Michael Kearns. He is the professor at the University of Pennsylvania, and he's also an Amazon Scholar for AI and machine learning. And with that, Michael, take it away.
Okay, thanks very much, Amanda. And I think I'm just going to speak off the proverbial cuff without any slides. So a little bit about myself. So I'm a career-long machine learning researcher. So suffice, I've seen quite a bit of change over the recent decades. And these days we see a great deal of discussion of policy, legal, and regulatory concerns around AI and machine learning. But what I want to talk about today, and what I think is much less well known, is that there is now a large scientific community devoted to technical approaches to these problems. In other words, trying to make algorithms and models better behaved in the first place. And I think I and my colleagues view this effort as important and complementary to kind of legal, regulatory, and policy solutions. And I want to tell you a little bit about this scientific endeavor today. The basic agenda of this scientific effort is to actually embed social norms like fairness, privacy, and explainability into algorithms. And when I say into algorithms, I mean literally there will be lines in your Python program that specify constraints around these social norms. And this scientific agenda necessarily has to begin with what is generally its hardest part, which is that if you're going to write Python lines that basically enforce fairness considerations, for example, you have to be exceedingly precise about definitions. So I would observe that computer scientists and machine learning types like myself are far from the first community of scholars to think hard about these types of problems. So if we pick up fairness in particular, for example, clearly philosophers have been thinking about these questions for millennia, and more recently economics and legal scholars have been thinking about these things very deeply. But what's different is that none of these fields have ever had the need or want to be as precise in what they mean by a word like fairness or privacy as you need to be if you're going to explain it to a computer. And my next observation is that this level of precision is necessary, but it's not sufficient. It is possible to be very precise in what one means about privacy or fairness, for example, and to get it wrong. And I'm going to give a couple of examples. And so I want to spend a few minutes telling you what this science looks like in two particular important cases. One is privacy and the other is fairness. So let's start with privacy. To the extent that we have privacy laws or regulations that are precise at all, which we generally don't, in particular, I would make the observation as a scientist that when people hold up the GDPR as kind of a model of strong modern regulation around algorithms and AI more generally, to somebody like me, I look at that, and except for very specific provisions around the right to be forgotten and things like that, the words privacy and fairness appear all over that document, and nowhere, anywhere in that document does it even come remotely close to saying what those words actually mean. And so when I look at a document like that, I think of it as largely ineffective and toothless, and I don't think it will survive challenges in court for that reason. But to get back to privacy, to the extent that we have privacy laws that are precise, they generally tend to specify anonymity techniques as the solution or as what's required. So think, removal of personally identifiable information as encoded in things like HIPAA, which is the body of law that governs healthcare and medical records in the United States. And so I think you all probably have some sense of what anonymization techniques look like. You go into the data set and you redact entirely certain columns like name and social security numbers and other things that you think might be strongly identifying of individuals. And you might coarsen other data. You might, instead of putting people's exact year and age in years, you might block it into 10-year periods, this kind of thing. And this has been the go-to method for privacy for many, many decades. And beginning in around 2000, people started to develop so-called re-identification attacks, showing that you could actually take allegedly anonymized data sets and perhaps combine them with other allegedly anonymized data sets or publicly available information, and actually re-identify the specific identities of individuals in that data set. And this started off basically a 10-year game of whack-a-mole, when somebody would effectively do a re-identification attack, and then researchers defending anonymity techniques would come up with some fix or patch that got around that problem, and then people would find the flaws in that. And basically, I would say that this ended around 2010, at which point anonymization techniques have been thoroughly discredited by anyone who thinks seriously about these topics. Around that same time, an alternative, different, and in many ways much improved, or I would almost say right notion of privacy was introduced, which is known as differential privacy. And in differential privacy, you actually end up with strong, provable guarantees of privacy at the individual data level, while still being able to do very useful aggregate computations. And the way this is achieved is essentially by adding noise and randomization to computations and data in a way that preserves statistical patterns, but obscures the contribution of any individual data point. There are now many widespread technology applications. So for example, if you use an iPhone, differential privacy is used to report a very noisy version of your app usage statistics to Apple periodically. And the high level idea is that, a large amount of noise is added to the histogram of your app usage, so much noise that it's meaningless. But when you aggregate 100 million such reports from iPhones, because the noise is independent, it averages out and you're left with very accurate aggregate statistics or histogram. The moonshot for differential privacy is underway even as we speak, because every single statistic and report being released by the US Census, which has started just happening this week, is being released under the constraint of differential privacy. So let me now say a few words about fairness. So again, to the extent that we have fairness laws or regulations that are precise, they tend to work by restricting the inputs that can be given to an algorithm or to a model. So for example, in the United States, since the 1970s, it has been against the law in consumer lending to use a process, model, or algorithm that takes race as an input. It is again unfortunate that it is easy to find real examples where this restriction is not only ineffective, but when combined with standard machine learning training techniques, actually results in racial bias against the particular group that you were trying to protect by that particular law or regulation. And it turns out that a much better way of getting to what we might call fairness in machine learning is to not restrict the inputs to the training or the model at all, but rather to explicitly enforce the fairness constraints that you want at the output. So to say it informally, instead of having the objective be the standard one in machine learning of minimizing our predictive error, we could instead minimize our predictive error subject to a fairness constraint. So in consumer lending, it might be minimize the error subject to the constraint that the false rejection rate between Black applicants and white applicants can be at most X%. And notice that when I put it that way and leave the value of X unspecified, I have a knob I can tune, right? If I set X to be 0%, then that means I demand absolute numerical parity in the false rejection rates between Black and white applicants. If I relax that to 1% or 5% or 10%, I have a weaker fairness constraint, and that might let me optimize the error better. And the reason I mention this somewhat technical point is that by varying this parameter X, we can actually quantitatively, on real data sets, trace out the trade-off that we face between error and unfairness. And there will, in general, be a trade-off, right? The stronger I make my fairness constraint, the worse my accuracy will be, and vice versa, okay? So that's a little flavor of what the world I live in looks like. And while there is a great deal that we still don't know, I think this endeavor is off to a pretty strong start. And there are basically many cases now where we already know how to, quote unquote, do better in the social sense in algorithm and model design. And so I want to just close with, well, so what are the legal regulatory implications of all of this? So first of all, I mean, I think the state of play right now is that for the most part, the adoption of these techniques is still optional and not widespread. And I think in part the reason it's not widespread is because it is optional. And more generally, I would remark that our current laws and regulations are woefully suited to the algorithmic era. They need to become much, much more precise and try to meet the type of science that I'm discussing here halfway or somewhere in between. And this will require both regulators and scientists understanding each other's worlds and constraints better and to develop a mutual language and understanding. And I'm optimistic that this will happen, but I'm also realistic in that I think that this will take long. This will take longer. This is going to take time because, you know, as usual, as in many situations, the science and technology are in some sense the easier parts, and the social piece is generally harder and slower. And so let me stop there.
Wow. To quote something I saw on LinkedIn recently, I think this kind of goes on with what I'm feeling. I'd rather have I wouldn't want a data scientist who can list like hundreds of algorithms for me. I'd rather have one who can explain one algorithm to just anybody. And Michael, I think you definitely crushed that. So thank you for that talk.
Thank you.
I have some questions for you, but we will wait after Jamise. So our next speaker is Dr. Jamise Sims. She is the NOAA Senior Science Advisor for AI. And it is my pleasure to introduce her. And now, Jamise, take it away.
Thank you, Amanda. It's certainly a pleasure to speak with you all today on this panel. Excellent talks already. It's very exciting to discuss artificial intelligence. So I do work for the National Oceanic and Atmospheric Administration, and I will talk about actually laying the foundation for how we use AI and then dive into the questions that we were asked to address. Next slide, please. So within NOAA, our mission is actually to provide guidance and information for decision support services, monitoring of the atmosphere and environment from the bottom of the ocean floor out to the sun. And so in order to do that, it certainly requires the collection of a lot of observational data, be it from satellite systems, autonomous systems, buoy, radar, et cetera. And our goal is, of course, to provide data and services to support disaster preparedness, response, and restoration. Over the last year, we saw $22 billion weather and climate disasters across the United States. And in order for us to meet our goals, we have to be able to take the data that we receive and be able to process it and also provide forecasts. And artificial intelligence is certainly a tool that we use in order to provide the best product. Next slide, please. So we define AI, when we talk about AI as an umbrella statement, we're including machine learning and deep learning, of course, and these are subsets of artificial intelligence. And so many of the uses across the agency have been for data quality control, even fishery surveys. I know that this is AMS and more focused on weather, but because of the amount of projects that we have in our fisheries office, I also wanted to make sure that we mention that here. Additionally, for model parameterization, automated weather warning, ocean robotics, environmental mapping, and hazard detection and identification. So again, as our data capabilities increase, we want to make sure that we have tools in place so that we can really and truly see the potential of the data. Next slide. In February 2020, NOAA released the Artificial Intelligence Strategy, and in January of 2021, we released the Artificial Intelligence Strategic Plan. And the purpose of those are truly to harmonize the use of artificial intelligence. You know, think of coordinating across all of our line offices to improve upon our products and services through the use of this tool. And so our 5 goals include making sure that we have the proper organizational structure in place. And we've stood up the National Center for Artificial Intelligence. Additionally, we look to advance AI research and accelerate research to applications, strengthen and expand partnerships, and make sure that we have a proficient workforce when it comes to the use of AI. Next slide. AI is not new to NOAA. Of course, it seems that within the most recent years, you know, AI seems to be evolving and we're hearing a lot more about artificial intelligence, but it's not new to NOAA. We've been using it for over 25 years now, mostly for machine learning applications for numerical weather and climate modeling systems. When we talk about data assimilation, also using neural networks for emulation of radiative transfer, physical parameterization, and things of that nature are some examples of how we've been using AI for our modeling systems. And so the key takeaway from this slide is that we do have expertise within our agency as it relates to AI, but we also, you know, have other things that we're learning right now in regards to AI as well. Next slide. So last year we did a data call to get a better understanding of how we are using artificial intelligence across the agency. And so in that, we found approximately 200 projects that are currently using AI. And this slide shows the distribution of that. Our key drivers for applications of AI and machine learning include the need to improve data assimilation and forecast modeling, as well as to accelerate the data processing of the big data collected from the emerging technologies, as I mentioned earlier. And so on the next slide, you can see the distribution of these applications. The y-axis on both of these slides are actually the number of projects. And so you can see here that the majority of our projects are related to satellite and meteorology. We also use AI in regards to underwater and aerial imagery, active and passive acoustics, electronic monitoring, and also other environmental areas as well. So again, we're using AI across all of our mission areas so that we can provide the best products and services. Next slide. So that brings me to the discussion points that we had here for us today to talk about. And the first point being, what are the sectors consistently seeing across AI policies and principles as well as guidelines? Within the federal government, we have certainly seen an increase of agencies developing strategies. We also have different the executive orders that have been put out that really and truly focus on trustworthy AI and how we will coordinate across the government in order to expand and develop our standards and policies. It is extremely important that we understand the different needs and bring those needs and requirements together so that we can create those the standards and policies that are needed to meet our needs today. And so those are certainly being developed, and NOAA is a partner in assisting with developing these standards. What types of methods and principles or guidelines are the sectors using? Again, getting back to our strategy, as well as the partnerships that we are developing. One of our key partners within NOAA is the NSF, the National Science Foundation AI Institute, on research for trustworthy AI in weather, climate, and coastal oceanography. And so we're partnering with that NSF Institute, which is led by the University of Oklahoma, Dr. Amy McGovern, in order to assist and better understand explainable AI, again, getting back to that trustworthiness. Also using risk management, as was spoken about earlier in the previous presentations. But we certainly look to our NOAA Center for AI as well to provide the AI data repositories, but also look to better facilitate discussions with our partners, getting back to creating the standards and the guidelines that we need to have in place. The current state gaps that we see, and I'll address this from both the gaps as well as the opportunities that we have. And so some of the key gaps that we're seeing are, first of all, our strategy looks to further identify what these gaps are beyond the need for the standards and the policies across the government. But having the AI-ready data means making sure that we understand the accessibility. What do we need to do to improve accessibility? And in regards to that, that includes us working closely with our data strategy as well as our cloud strategy. Additionally, understanding the format needs as well as labeling for AI data. And so in working together and in getting that understanding, we can certainly even evolve and improve upon, where we are now, but we certainly have to collaborate in these areas. Additionally, a gap that we're seeing is the need to really and truly leverage the expertise when it comes to artificial intelligence. And so if we actually skip through the next two slides, I think we can get to where I talk more about the workforce. think it was, yes, this one. So our NOAA Science and Technology, as well as our information resource management strategies, really and truly demand having a diverse and inclusive workforce. We want to make sure that we are reflecting and understanding and being able to respond to the varied communities and stakeholder needs. Basically getting back to what Dr. Kearns was just speaking about in his presentation. Additionally, we want to make sure that we do have the training resources in place to upskill the current workforce, and also collaborate with our Office of Education to provide student internships to our cooperative science centers, as well as working with our cooperative institutes in order to train the future workforce as well. Our partners will certainly allow us to leverage expertise within our agency as well. Next slide. So again, our partnerships serve as a force multiplier. Getting back to developing the trustworthy AI, we certainly have to be able to understand what these needs are. Again, the three that I talked about being accessibility, the formats, as well as labeling of AI data. And we have key partnerships right now that we are working with. In addition to the academic institutions, we're also partnering with Google as well. We have an agreement with Google that will allow us to better understand how we can exploit our satellite observations for the improvement of our weather models. And so in doing that, again, making sure that we have that explainable AI will certainly be important here. I mentioned before about partnering with the data and cloud strategies within NOAA, as well as the big data program, in order to leverage these services that are foundational for enhancing AI-ready data access and workflows for AI analytics. And so that's pretty much the NOAA overview of AI, and I look forward to our discussion.
Thank you so much, Jamise. That was incredible as well. I really enjoyed how you pointed out many times throughout your presentation the need for partnerships, because we can't do this just in individual lanes. We have to do this together. Thank you so much to all our presenters. I encourage everyone, if you have a question for any of our panelists, please put it in the chat. I will be happy to ask the question for you. If anybody, if not, then I think I'm going to take this upon myself as an opportunity to ask my own questions. With that, I will probably start. I will start actually with Kirk, since you are our first presentation. So I liked that you pointed out that sometimes you have to work with third-party vendors, because that was one of the things I was wondering too, because you guys do a lot of, you provide hardware, right? Mm-hmm. And so when you have to work with other people who do more with infrastructure and software, how do you what's the biggest red flag you've seen when you've had to work with third-party vendors? What's kind of something that comes up a lot within HPE when working with them, trying to follow your own AI policies and guidelines?
There's a lot that happens. Some areas are inherently challenging. Anything with facial recognition is an area where there's certainly been quite a lot of concern, very valid concern, not only on the application and why the technology was being used, but it also, I mean, when we want to humanize something, we say, well, you put a face on it, right? So even the term itself, it just shows to what a challenging area it is when something is that human-centric, and understanding how both we do the training of the model, but also how we understand the implications and the behaviors that go around the operational principles. So I think we want to consider the entire ramifications. When we talk about things being robust, We want them to be robust not only from potential errors, but also from potential attacks. And have you actually set up a system now that is essentially a honeypot, that is a target of great opportunity? So understanding how you're protecting, maintaining this data, making sure that the systems that you create, you have engineered them to be as robust and resilient as possible against, not just in foreseeable misuse or against bias, but also against potential attack. And then to having that conversation, sometimes it's something that people haven't been considering. They have this great algorithm, it's doing fantastic scores, and then you ask them about the operational principle and the ramifications of operating such a system, and they haven't necessarily gotten that far in the thought process. So sometimes, again, that's that engagement we want to have, bringing our perspective onto it, and helping educate them and considering, have you considered your supply chains? Have you considered the ramifications of operating the system? Have you trained the population of consumers so they know what is appropriate and what is not appropriate use? And are you following up? And that's why we had in that last of the little quadrant was the assurance. We've set these things up. Now let's make sure that the systems and guarantees we've set up are actually operational.
Thank you. And since you mentioned the word bias, and this is for everybody, anybody can respond. How often do any of you find that you have to absolutely define what you mean when you say the word bias? Because sometimes when you get into a room, you say the word bias, it's taken more in the context of a political bias of sorts, and not so much as the actual scientific mathematical term of bias. When do you have you found that there have been misunderstandings, and how important is it to define certain terms when you're talking to partners or vendors?
Well, let's see. So I definitely think it's important to be as precise as one can be about, definitions and what you mean when you say a word, especially when at the end of the day, something's going to get implemented in an algorithm and model anyway. And so if you're not clear or don't say anything, or you say something imprecise, you run the risk of something different than what you intended happening. I don't, in general, I don't often find myself in situations where people specifically are confusing the meaning of the term bias in the statistics bias variance sense versus unwanted discrimination against a particular group. And if that's a confusion, usually you're talking to somebody who knows what bias and variance is in statistics, and so you can quickly explain to them you mean this other thing, and it's not really a barrier.
Janice, I think you wanted to respond.
Sure. From our standpoint in using artificial intelligence mostly to solve complex, scientific problems that we have. When we talk about biases, as Mike just mentioned, we are referring to those statistical analysis, right, within our models, and making sure that we understand what our errors are and how our models are biased, particularly for developing forecasts. We want to make sure that we understand those biases, because if we don't, we can just take a look at what the model says and, provide information off of that. And so even though we are constantly improving our models, and we certainly have good output from our models, this kind of goes back to the importance of having the human in the loop as well, making sure that we have the human in the loop that can, understand what the output is and provide the information that's needed for the public, because what we look to do is certainly save lives and property. But just going back to the need for AI-ready data, we want to make sure that we are providing clean data when it comes to these AI algorithms, because if we are using bad data, then our output is bad and we have more biases. So it's important to understand that and be able to, work through that. And I really like what Kurt said earlier about understanding where we should not use AI, because a lot of times, especially now, it seems as if some people hear the word artificial intelligence and oftentimes think that it's an end all be all, like it can solve every problem. And that's certainly not the case. So we do have to not only understand, where we should use it, but also where we shouldn't. And a lot of that goes back to knowing what those biases are.
Jimmy said that one thing that's really part of our research agenda is understanding how we establish those systems of data provenance. And it's really for two reasons. One is, as you say, so that I have confidence. This isn't a model that's been trained on false signal that may have been injected by an adversary. It is something we can actually have confidence and measurable. I mean, all of these confidence that's an interval we can measure. We can actually establish and have some rigor on that. And that can mean things that really need to go back to, how do I understand the sensor that captured the data? And what was the supply chain that created that? All the way through all the transformations, all through the training, all through the model, all through the inference. So understanding the entire data pipeline is there. The other aspect is, especially when they are human factors. As we gather data, we gather and accrue responsibility to the people whose lives have shaped that data. And so being able to understand and maintain that responsibility and what we owe the individuals who helped create those data sets to make sure that they are equitably included in the outcomes is another element of this. So understanding, how do we construct the systems of provenance all the way sometimes back to the silicon and bring those forward so that we can have confidence in these systems, that they can be operated in that human-centric viewpoint. One of the most argumentative parts we had during drafting our principles was understanding that human in the loop and that right to appeal. And I had someone argue with me, you're saying that you're going to give someone a get out of jail free card. Sometimes we mean that literally, right? If these are applied to legal cases, I said yes, until we can meet and apply the kind of systems that Michael was talking about that are explicable and auditable, then no, we do need to incorporate this. It may be fantastically effective, but when you don't have that explicability, you have to build in a safeguard.
Wonderful. Just to give everyone an update, we have 8 minutes left. I have another question, but now that we finally have people kicking in, I'm going to try to ask both these questions as well. We had a question from Heidi Santella. Sorry, I mispronounced it. I'm sorry. If you could give advice to the students, early career individuals in the room, what words of wisdom would you share on the skill development and coursework if they are interested in this area of study? So I'm going to start with Michael, and then I'll work to Jamise, then Kirk.
Yeah, well, I'm going to give a biased answer here, obviously, but I think at the end of the day, these topics have a strong technical quantitative component. I don't think they are only technical or quantitative, but whatever your interest is, including if it's on the policy, legal, regulatory side, the more you can know about what actually happens under the hood, the better off you will be to, meet your goals. Just to riff on that comment for a minute, when I look at the current regulatory landscape on technology in the United States, I think the single biggest problem is the staffing at the regulatory agencies. They're smart people, they know a lot, they are woefully unequipped to understand the technology of the companies that they regulate. And until that gets fixed, things won't get better. So that would be my advice.
Michael, I definitely second that. It's hard knowing that those are the ones writing the policies and guidelines, yet they don't know the intricacies of the things that they're writing to govern them. Thank you. Jamise, would you like to respond?
Yes, definitely. When it comes to skill development for artificial intelligence in particular, of course, you want to have a strong skill set in computer programming. And it's interesting that I say have a strong set because my first summer internship with NOAA was actually using a genetic algorithm to parameterize the model that was locating the Gulf Stream. And so when I started the internship, I had, I had a little bit of experience with computer programming, but not a lot. But by the end of the summer, I was an expert. And so, my advice is to, certainly take your computer programming courses, math courses, calculus, things like that. The statistical analysis are also extremely important. But now, there are more courses being offered in universities, specifically for data analytics, as well as deep learning. And machine learning. So take advantage of those as well. Additionally, there are opportunities for training in AI, being created that you can take as short courses, even through AMS, but also throughout other entities across the summer and throughout the year. So also look out for those as well. But if you can certainly try to get an internship, that will give you some hands-on experience in the different areas that you're looking to do. I certainly encourage that as well. And NOAA does provide internships every year, so be on the lookout for a chance to apply to those.
So I think, yeah, I'm going to agree with both of you. And if I had to pick one thing, learn Python, right? So right now, that is the lingua franca. Although it's funny, we think of, when we thought of the first web technologies, oh, you got to learn how to program, you have to code up and write it in HTML or JavaScript. And pretty soon it didn't matter, right? Because it became a pervasive technology and tools evolved. And then it was much more about understanding, how do you craft a user experience that's compelling, rather than knowing which HTML tag to put where. And so I guess for me, that's, coming back to it, that data analytic, that fundamental in statistics. I mean, part of the challenge we have is that a lot of people don't remember their calculus course, and they may never even had a stats course. So that basic ability to understand that, at least a lot of today's AI and ML, especially the ML technologies, it is really the math, and there's lots of ways we look at it, but it ends up being probs and stats, and being fluent in that, in that, just sort of that base understanding, I think, will advance you. And then, whether or not you go deep into the code right now, or you wait for the tools to improve. But there shouldn't be anyone on this call who thinks, oh, my particular discipline is probably not going to be affected. Now, this is a pervasive technology. And I don't care if you're an artist, an engineer, or a policymaker, this is something that you should begin to appreciate.
Yeah, I think you're going to get a lot of support in this room with Python rules. So I'm going to ask one more question from Dr. Gina Aosco, and I'm sorry if I mispronounced that as well. She says, we've been thinking a lot about AI ML in the social sciences, especially as it relates to creating an economic value chain data system, such as linking textual data or policy documents to show connections between user needs with R&D to operationalization. What role does text data play in any of your AI ML initiatives? Do the same lessons learned apply? Okay, I will assign someone. Michael, how about you?
Yeah, I mean, so definitely the same issues arise. I think broadly speaking, it's fair to say that, issues of fairness, for example, in textual or natural language problems are more complicated than they are if you're just producing a neural network that's making a decision, for example, because the outputs of NLP or text-based systems are typically much more complicated than simply a prediction or a number. They are something like, an input sentence in English and then an output sentence in Spanish, for example, in the case of language translation. And as you may know, these days, there have been massive strides made in very recent years at building kind of underlying language models that aren't trained for any particular task and are the basis for more specific tasks built on top of them. So I'm talking about things like word embedding models, or things like BERT, if you've heard of BERT, which has come out in the past couple of years. And so there, the issues of bias are a little bit more buried, right? And they're buried in the form that, the word doctor will typically be associated with male, and the word nurse will typically be associated with female, because this is reflecting a bias in the training corpus that was used to develop these kinds of models. And so I would say it's harder to audit these types of systems for the biases that they have, but no less important. There's a whole subfield of the area I work in that is devoted to kind of the specific types of bias that creeps in computer vision applications or speech recognition applications or NLP. And these are all challenging problems, but obviously the same issues are there.
Sorry about that. My video is lagging a little bit. With that, if you want, we can grab one more comment, but it is 1 o'clock. I will leave that up to you guys to let me know if you want to say something.
Just one last thing, and I think it's something that Michael hit on a couple times. And one of the side hustles I get to do is participate in a lot of World Economic Forum efforts on behalf of Hewlett Packard Enterprise. And one of the ones I'm doing right now is the Global Future Council on Agile Governance. And Michael, to your point of understanding where is that intersection between a regulated industry, the regulator, the population that we don't just want to protect them, we actually want them to thrive, and understanding how these technology threads are coming in there. I think it's encouraging to me. That we're actually they don't want to just borrow the term agile development from software development and then say, I'm an agile government. No, they actually are trying to understand the deeper ramifications, and having a conversation like that, because that's really what's required here, is for them to be conversant and understand, and how do we really adapt the process that all of the methodologies of agile development, and then bring them into the public sphere, to both have better regulatory frameworks in general, but specifically when we want to take the best advantage with the least risk about novel technologies.
Thank you so much, Kirk. And honestly, it's really been my pleasure to be the moderator for you guys. Michael, Jamise, Kirk, thank you so much. Each one of your perspectives is just the right twist that we needed as far as what you're experiencing with AI policy. I look forward to talking with you guys later. And Michael, I still had my question for you, but I will save that. Thank you so much, you guys. And I will turn this over to Jen.
Yes, and apparently my camera is having problems again, and that was a fabulous presentation and great panel. Amanda and Scott, thank you for setting this up, and thank you to our 3 panelists. Really enjoyed it. We have our next Ocean Enterprise keynote, the New Blue Economy, with somebody that we are all looking to hear from, and that's Dr. Rick Spinrad. So without further ado, we're going to close, and we'll be back at 1:15. Thank you so much.